Hello, once again, you are welcome back uh, on this virtual class. We continue from where we stopped uh, in logarithm. Here we are going to, be looking at some questions based on what we have discussed in the previous video, Introduction to Logarithm. Here we apply the laws and use them to resolve a question. So before us here, the first question is log a to base a plus log the square root of a to base a. Here we have seen that there is addition sign here and the base are the same. What we naturally do if that is the case, we say this is log, the question is log a plus log AA, log a to base a, and log square root of a to base a. Here, because this is addition sign and the two bases are the same, we simply say that this is equivalent to log, put the log outside to the base, which is a, and we multiply the logarithm, which is a times square root of a. But if you look at this term here, this is a raised to power 1 times a raised to power half. And we apply indices here. If we apply indices here, this will become a raised to power 1 plus half. And 1 plus half is equivalent to 3, equivalent to a, this is equivalent to a raised to power 3 over 2. If you take the LCM of this fraction, the LCM is 2, 2 divided 1 is 2, 2 times 1 is 2, 2 divided 2 is 1, 1 times 1 is 1, so 2 plus 1 is 3 over 2. Then let's put it in this equation here in the question on the right hand side. This is log to base, this become a raised to power 3 over 2 to base a, and from the one of the laws that we discussed, if we have a log x raised to power n base a, it means n log a x. So this will be applied here, and this will becomes 3 over 2 log a to base a, and we know that this is equivalent to 1. Log a is 1, so our answer becomes 3 over 2. So we can see that this result here is simply 3 over 2. Okay, then let's look at the second question. That is number 2. Number 2 question is this. We have a log 4 plus 2 log 5. Here we need to do some transformation. First thing, we must know that the base here is not shown. That means this number is to base 10. That's what we should know. Then we have to reverse this law. So because we said that log base a x raised to power n is n of this. So that means this one, we'll move it this way, and become log 4 plus log 5 raised to power 2. Because the bases are the same, we will apply the rules. Addition will multiply here. Here become log, open bracket 4, 5 square is 25. This become log what? Log 100. We know that the base is 10, and log 100, this becomes log 10 square, and this becomes 2 log 10, and this is the base are the same. That means the answer here becomes 2. for this expression. Okay, now let's look at this logarithm. Number 3. Number 3. Let's look at number 3. Number 3. Say log base 3 2.7 plus log 10 to base 3. Here we are seeing multiplication and the base are the same. So this is addition. So that means it is multiplications because the base are what? They are the same. So here we can write this. This is log base 3 2.7 times 10. Okay, this log base 3 2.7 is the same thing as 27 over 10. So that this will go with this. Here become log 3 or 27. So here we can say this log, let it be a, that 27 here is equal to 3 raised to power a. So how many times are we going to multiply 3? With 3 multiply itself to give us 27 is 3. So here is 3 raised to power 3 is equal to 3 raised to power a. Now a here is equal to 3. So this logarithm is equal to what? Equals to 3. From definition. Okay, now let's look at this. Number 4. The one that we have already treated. Let's pull them off. Yes, let's look at question number 4. Is log 100 divide root 10. Here, without being told, the base is 10 because it is not indicated in the question. But we apply, first of all, what we do here, we apply indices. We need to apply indices. This one means 100 divide root 10. So we can apply indices here first, or we can, transform the question back to applying the law. Okay, here this is 10. This is 10 square divide 10 raised to power half. Okay, so here take note. This is we are seeing log. We see operating with this log attached to it. Okay, then in that case, we will see that from indices, this 10, because this is division and the base are the same, this become 2 minus half. 2 minus half, and the LCM here is 10 raised to power. The LCM is 2. 2 divided 1 is 2. 2 times 2 is 4. Negative. Then 2 divided by 2 is 1. 1 times 1 is 1. So here everything becomes 10 raised to power 3 over 2. And I said that this, what we have here, all this 10 here, this become log 10 raised to power 3 over 2. Remember the power rule here. This 3 over 2 will come behind, become 3 over 2 log what? Log 10. So log 10 is what? Log 10 is 1. Because the base is not indicated here, that means it's 1. So here this become 3 over 2 times 1. So therefore, this logarithm is the answer is 3 over 2. Okay, we are done with that. Let's look at number 7. Number 7. Number 7 here. Look at the question before us. Number 5. Please. Is 5 raised to the power of log open bracket 1 over 32 raised to the power of 1 over 5 log, the base is 5. Base 5. And from the log, we said the other time, if we have a raised power the log of any number x to base a, this result is just x. So that means everything here, all this logarithm we are seeing here now, these are off, and what we'll be treating here is just 1 over 32 raised to power 1 over 5. Okay, raised to power what? 1 over 5. And here, this 32 simply means 32, 1 over 32 simply means 32 raised to power minus 1 times 1 over 5. Okay, here, this 32, you can express it as 2 raised to power 5, and there's minus here, 2 raised to power minus 5 times 1 over what? Over 5. So this will go with this, and we'll be left with 2 raised to power minus 1. So 2 so here our result becomes 2 raised to power minus 1, which is the same thing as 1 over 2. The whole of this logarithm, log of 5 raised to power log base 5, 1 over 32 raised to power 1 over 5 is equals to 1 over 2, equals to 1 over 2. Okay, now let's look at question number 6. Question number 6. Look at the question carefully. Question 6 is 2 log 2 over 5 minus log 75 over 125 plus log 9. If you look at this logarithm, the base are not given, so it assumes that they are all to base 10. So, but we have to do some here we have to do some transformation. We'll move this one back, and this 2 become the power of what we have here, 2 over 5 all square minus log 75 over 125 plus log 9. Log 9. Here we have to observe this is minus, that means division. This is what? Plus, that means it's times. So here we do this become log. We close our bracket here. This is 2 square, give us 4. 5 square give us what? 25 times 9. Here there's minus, become divide 75 over 125. So we close our bracket here. So we do the operation. The operation continues. This becomes 4 over 25 times 9. This sign here, division change to multiplication, and we vert the denominator. This becomes 125 over 75. So 5 here, 1, 5 here is 3. Okay. 3 here, 1. 3 here is 3 is 75. This is 25. Okay. And here become log, this will become log 36 over 25. Okay, so here there's no way we can simplify further. We will leave our answer in this manner, or we can simplify further. We can say this one is log 36 minus log 25. And here it can also be written as 2 log 6. 36 is 6 square, so the square, the power here will come back. Similarly, here this is log 5. 25 is 5 squared. This become 2 log 5. So we can leave our answer in this manner, or we say 2 open bracket log 6 minus log 5 as our final answer. Okay, then let's now look at the question. Let's look at question 7. Question 7, I see what he has for us. Question 7 is this 7. Question 7 is log root 8 to base 2 plus log root 3 to base 3. So we should resolve this. It's a very good question. Okay, let's look at how to resolve these questions. Very, very important here. Now we can see here that this base here is different and this base is different. So we cannot use, the law cannot work here. What we need to do, we say, we assign that let this is equal to A, and maybe let this one, okay, let this one is U, and this one is what? Let this one be V. So that we cannot write that log base 2 root 8 is equal to U. Here, that means root 8 means 8 raised to power half is equal to, from definition here, to be 2 raised to power U. Okay? Then, how many times will we multiply 2? 2 will multiply itself to give us 8. Is 2 is 8 is 3. So this one will be 2 raised to power 3 times the power we have there before half is equal to 2 raised to power U. Here U will go with U. 2 will go with 2, and with the power U is equal to 3 over 2. Okay. Similarly, we will do the same thing to V. We say let log root 3 base 3 is equal to V, so that our root 3 simply means 3 raised to power half is equal to 3 raised to power V. So that here our V is equal to what? Is equal to half. Because we are saying let this one is equal to this, and let this equal to this, and we are having here, this will become U plus V. Our U is 3 over 2. Our V is half. So by the time we do this, LCM is the same. It's 2, 3 plus 1. That will give us 4. 4 divided by 2 is 2. So we see that this logarithm, log root 8 to base 2 plus log root 3 to base 3 is equal to 2. So first thing you do, because the bases are not the same, you operate this one, find the value, operate this and find the value, then you sum the result together. In order for us to finish this class, let's look at this question. Before all, the last one, number 8. Yeah, number 8. We have a half log 8 over 4 plus log please log 8 to base 4 and the log 32 to base 4 minus log 2 to base 4. Okay, here what we need to do, this half has to come here first. We need to, abide by the rules, the laws. So here we have, because the bases are the same, another thing you should look at for is the base, they are the same. So this becomes log base 4, 8 raised to power half plus log 32 to base 4 minus log 2 to base 4. So here we cannot operate using the the rule here. Addition will multiply, subtraction will divide. So here we'll put out log to base 4. Here will be 8 raised to the power half times 32 divide by 2. So we are going to do a lot of work here. So we must here this is 2. We can raise 8 to the power of 2. We can also raise 2 to the power of 32. So we're going to change all this one to the common number of 2, the power of, using base as 2. So here we have a log of 4. Yet 8 is 2 raised to the power 3, and this 3 here, the 3 we multiply this out, become 3 over 2 times 32 is 2 raised to the power 5. Here divide by 2 raised to the power 1. So here indices have to come into operation. Indices has to come into what? Operations. So and if we do that, we see that here we are having log whose base is 4. The base is common, which is 2 now. This is multiplications. Here will be 3 over 2 plus 5 minus 1 here. So that's what will happen there. So here 5 minus 1 is 4, and we have a log base 4, 2 raised to the power 3 over 2 plus 4. The LCM is 2. 3, 2 divided by 2 is 1. 1 times 3 is 3. 2 divided by 1 is 2. 2 times 4, that will give us 8. So here we have 2 raised to the power 11 over 2. That is the expression there. Then you see this base here. There's nothing common with this and this. But here we can say, we'll now continue to say, let the whole of this logarithm, because let's say it's u, so that we have a 2 raised to the power 2, so that we have a 2 raised to the power half is equals to 4 raised to the power u. Okay, here this 4 we can make it to be 2 here. So here we have a 2 raised to the power half is equals to 2 raised to the power 2u. Is that okay? Equals to 2 raised to the power u. So that here half is equals to 2u. So that u is equals to 1 over 4. Therefore, this logarithm is half log 8 base 4 plus log 32 base 4 minus log 2 base 4 is equals to 1 over 4. Okay, here we'll stop here. In our next class, we'll continue by exploring other aspects of logarithm. Have a nice time. See you in my next virtual class.